to the South Main Auto Channel. So we've got this 2006 F-150 with the 5.4. The guy stopped in around lunchtime today and said his dash was doing some funny things. The gauges were twitching and he couldn't read the radio display and the wipers quit working. And long story short, he went out to his truck and I told him that he could leave it and I'd take a look at it. And when he went out, the truck was dead and dead. Won't crank, won't do anything. So needless to say, he left it. I went out a little after lunch, attempted to start it, and it's obviously a dead battery, just click a little bit. I threw a charger on it at 10 amps for a couple hours, get a little juice back in the battery. Started it up, took the voltmeter on the battery, and noticed we had no charging voltage. But what's got me a little bit concerned, and I guess what inspired the video, is the fact there's no lights on the dash. There's no battery charging light, there's no check engine light, and this uses what they call a smart charging system. It's a charging system that Ford's had for quite some time. I think perhaps even back to 99, early 2000, somewheres in there, right up through the years, maybe 2010, somewheres in that area. But it's a common system on the pickups, the cars, the SUVs. So, is it really the alternator? Not real sure. I'll show you guys what it's doing, and then we're going to grab our scope and we're going to check the charging system to see if it's getting the correct inputs, outputs, and indeed if it is an alternator. So with the key check, the engine light works, the battery light works. We do have a volt gauge down there, and that's about halfway. So when we start it, it stays about where it was. We had a load, it dropped slightly. Let me kick on heated mirrors, kick the blower on, everything drops it down. Let me take and rev it up here. And yeah, voltage stays about the same. We'll cut off some of our loads, and we can see the gauge comes up slightly. So we'll load up the scan tool here, go through, make sure I'm not crazy. The battery was dead, so I do expect to see at least a P1000 in here. But just kind of, like I say, kind of sparked my interest, the fact that the light's not on. And typically, the way these communicate, we usually throw a light, at least a battery light. The alternator, the ECM talks to the alternator. It's got a P1000 and then a misfire on startup, so no surprise there. And like I was saying, the ECM talks to these alternators and the alternator talks to the ECM. It's kind of a, I won't say a checks and balance, but what do they call it? You got your Gen Com line and your Gen Mon line, so your communication and your monitor line is kind of what they talk on. So the ECM will command the alternator at a certain set voltage based on air temperature, engine load, various items, battery voltage, electrical load, quite a few parameters there, it looks like, and then the alternator reports back essentially what it's doing. I'll get the what do I want to say? I'm losing my mind tonight. It's getting late. The criteria or the theory and operation, I guess if you will, on this alternator, and then we'll look at a wiring diagram. I'll show you what we're going to test, and we'll kind of hypothesize what we should see, and we'll take a look at it and see what we do see. Okay, so I got us a wiring diagram there. I did print out the principles of operation for this, so I'll kind of read through this as we look at the diagram. So obviously, battery, generator, we've got our engine computer, instrument cluster. So pretty straightforward there as far as that goes. It states here that the PCM, controlled charging system, determines the optimal voltage set point for the charging system and communicates this information to the voltage regulator. So like I was saying, the ECM essentially talks to the generator. This system is unique in that it has two unidirectional communication lines between the PCM and the generator regulator. So we have these two lines, this Gen Mon, Gen Com. They're unidirectional, so they either transmit, this one transmits or that one transmits. They only go one way. The Gen Com, so the generator communication line, communicates a desired set point from the PCM to the regulator. So the Gen Com line, that's this one here, that's going to send information to the generator. Let's see, where were we? The gen monitor, the generator monitor, the gen mon line, communicates the generator load and error condition to the PCM. So it's going to be this line here. So that is going to be our outgoing signal to the PCM. The third pin on the voltage regulator, the A circuit pin, is a detectable battery voltage sense line. So that is going to be this line here, and that's sometimes referred to as gen sense. So this one should be our battery voltage. So we'll just mark that with a positive. And then this is your big battery terminal here. That's going to be your big heavy gauge wire on the alternator that goes directly to the battery, as does the gen sense wire. That also is just fed directly from the same side of the battery, obviously positive side, but looks like they tie into the same splice. Let's see, then it says here, the charging system voltage is controlled by the PCM, which we determined. The generator charges the battery, and at the same time supplies power for all the electrical loads that are required. The battery is more effectively charged with a higher voltage when the battery is cold, or a lower voltage when the battery is warm. The PCM is able to adjust charging voltage according to the battery temperature by using a signal from the intake air temp sensor. Okay, so that's what I was mentioning. It takes a input, at least that input, to customize this charging strategy. This means the voltage set point is calculated by the PCM and communicated to the regulator by the COM link, so the gen COM. So the ECM takes in various inputs and then outputs, you know, what it sees fit to the generator, to the regulator. The regulator in turn, you know, uses logic to, you know, charge the, or, you know, control the output of the generator. The PCM simultaneously controls and monitors the output of the generator. When the current consumption is high, the battery is discharged, the system is able to increase the idle speed. So that's kind of a neat fact to know. To minimize engine drag when starting the engine, the PCM controls the generator. The generator does not produce any output until the engine is started. The PCM then progressively increases the output to the generator. So that's something good to know. Let's see here. The PCM controls the operation of the charging system warning indicator in the instrument cluster. The PCM is responsible for turning the charging system warning indicator off after the engine is started and illuminating it under fault conditions when the generator is not generating the correct amount of current with the engine running. So why isn't our light on? The charging system warning indicator is also illuminated by the PCM key on engine off and stall conditions. This is a System 4 charging system which uses Gen Mon and Gen Com lines to control and monitor the charging system through the PCM. System 4 charging systems are virtually identical in design and therefore share the same diagnostics. Okay, so another source that I have is a book that was at one of our training seminars that I went to. It explains this charging system actually in a case study that was in this book on an overcharging condition they had on a Ford Taurus, but it does give us a little more information on our Gen Com and our Gen Mon lines, because like I say, even though this was on an older Ford Taurus, you know, very similar system, it indicates here that the Gen Mon line, it's a duty cycle controlled signal, like we read in our literature there, where it says both COM lines are pulse width modulated, so we're expecting to see, you know, a square wave pulse width modulated signal being generated from both COM lines. So that's a tidbit of information, so we can apply that to what we think we'll see. You know, we'll see that, or, you know, we'll see it, you know, just pulled high or pulled low, something along those lines. It states that the Gen Mon, okay, so this is from the generator to the ECM, duty cycle controlled signal is output continuously. So I'm assuming key on, engine off. The duty cycle of the signal is proportional to the electrical load, and the scanner will always read a percent duty cycle between 5 and 95%. So on this signal, on the gen mon, when we hook our scope to it, this is what I'm expecting to see, a square wave, whether it's 0 to 5 or 0 to 10 or 12, whatever it is. We're not real clear on that. Let's see. So on the gen com line it states, so it's going to be from the PCM to the generator. The PCM communicates the desired charging system set point to the voltage regulator. The gen com pulse train output is periodic and output at least every 5 seconds. All right. The duty cycle of these pulse trains equates to the PCM desired voltage set point. The scanner will read a voltage, sometimes listed as gen VDSD, so gen voltage sense. So at any rate, I am expecting on gen com line, so from the ECM to the generator, we're also going to see a duty cycle, but perhaps periodically, according to our information, and at least every 5 seconds. So it may be sent kind of similar to, what you would see on a communication line, like a CAN line. There might be, a long pause. It may send some, I guess for lack of better term, some data packets, and a long pause, and then it's going to, communicate with this generator some more to make fine-tune adjustments. We're also going to look at this on the scan tool at the same time. So that's the plan. Let's get hooked up. So I guess the first thing we can do, just sitting inside the truck, make some observations about the data pins I found. So it is reading battery voltage at the computer. I don't know why we've got that one on there. Right now the command is actually being sent at 6% to the generator. Generator fault lights on because it's key on engine off. The monitor line, so this is going to be the signal sent from the generator, is at 0%. I thought our literature stated that that was sent all the time. That one was continuous and this one is periodic. Says there's no fault, desired voltage is 12.1, and then I put intake air temp on there because that was the pit it looked at. So let's just go ahead and we'll start it up, make some observations. Alright, so the monitor is at 96%. You can see it's ramping up the alternator like it told us it would. And then it goes right to 0. Let me just start that one more time. So that's pretty interesting. The desired voltage went up to 14.4. But we can watch the command being sent from the ECM. If you remember right when we read the literature that it says, after initial startup it builds it up slowly. But you see that got to 50% and then it just shut right down. But as it was ramping up and the gen com output was being received, or the gen monitor was being received from the alternator, the battery charging voltage did not change. So we start it. It's sending the command. The monitor is sending the output. And nothing. It immediately shuts down with no change in system voltage. Interesting. Went ahead and fired up the Pico. I've got that hanging there with the big spaghetti mess of wires, trying not to get caught in the fan. I've just hooked over there on the battery negative. I've made the other 4 connections on the 4 connections available at the generator. So the battery plus, gen sense, com, and mon line. And to make it easier, I have them labeled down here. So channel A, so our blue trace is our alternator voltage at the alternator battery positive post. Channel B, so our red lead, is alternator gen sense wire. Now remember on the wire diagram, if we look at that, that's going to be those 2 wires. We're expecting to see battery voltage on those. And we can take a look. I've got some channels pulled up here, some measurements, and we've got 11.52 volts on both those, 11.52 and 11.55. So it's 11.5 volts on both of those. Our green trace, I've got that labeled as the COM wire, the alternator COM wire. So if we remember from what we read, the COM wire is the one that's being outputted from the ECM. That's the ECM talking to the generator. And that's the one that I thought was supposed to be periodic, or that we read was periodic, but you know, we're key on engine off, so there may be something there I didn't read or missed. Now our yellow trace here is the gen.Mon wire, and from our wire diagram, that is going to be the wire going out to the out to the ECM, saying it gives its state of health check, its errors. How else was it? Let me grab my paper. It gets late at night and I start losing my train of thought. What is it? About 8 o'clock. Let's see. gen.Mon. The generator mon line communicates the generator load and error condition to the PCM. So that's giving a little bit of data to the PCM. Anyhow, keep trucking. And we can see when that runs live that there's nothing on it. You know, it's just holding around 0 volts there. So one observation we can make sure this is legit. What are we looking at? The generator COM wire. So COM being from ECM to alternator, we can see it's running at a duty cycle of about 7%. At least on that capture. I'll capture full screen here. So 7.62%. We see on our scan tool 6%. So that's really close. I don't know how often the scan tool updates. So that looks good. That's the one being, that's the one being sent from the ECM. So we got no questions as far as a wire is concerned. Well, let's fire it up. Let's see what happens. First thing, I just want to save my waveform here. Oops, what the heck did I do? There we go. All right, that's all saved. Let's let it run live. Now we remember, oh, did I have an active screen there? Now we remember when we first started the vehicle, our command duty cycle started to increase and our gen.Mon came on, and then all of a sudden our generator command went away, went to 0%. So, all right, here we go. Hey, well, there we go. Yep, and I'm watching the scan tool, and we just lost the command. But I wonder if that's one of those, that's the periodic talk. So let's just have a quick look at that. This is the ECM talking to the generator. All right, very interesting. So we'll see if it's about a 4 or 5 second glitch between those. 1, 2, 3, 4, 5, 6, yeah, about 5 seconds roughly. We can see on our COM wire about 97% duty cycle. And that's about what we're at here, 96%. And our battery voltage is staying low. So that's pretty interesting that we have what seems to be everything required to make this system charge, yet it's not charging. See how often it communicates here. That's about every 5 seconds. Well, I'll be jiggered. just wait for him. I'm gonna shut the truck off. I'm gonna save this for my data. Sometimes I don't have the answers, folks. And in this case, I don't have the answer. Perhaps when the generator communicates to the ECM, it's not sending the correct data to say, hey, I'm screwed up. And that's what I thought. So what I did off camera is I just took a test light, hooked the battery negative, and I shorted the comm line, and then I shorted the monitor line, and still it would not generate a code. I would suspect, because, you know, looking at those signals, you know, I mean, it looks good. As far as, you know, what information we have and, you know, what it says it should look like and how it says it should communicate, they look like it's doing its job. So I could understand perhaps ECM sees that besides the lack of battery voltage, it may be satisfied because, you know, if it's only looking at, you know, comm in, comm out, then yeah, it's going to be happy. So I thought, well, let's just take and pull one of those lines down. Test light battery negative, stick it in there, takes the, you know, the duty cycle, the control right away from it. Just boop, pops it right to the ground. Nothing. Rev the truck up a little bit, shut it off, start it up. Test light plugged in, nothing. Took the test light to battery 12 volts, ran both signals high, no codes. I don't know, maybe the ECM's confused. It appears to be in control or have some sort of control and sending signals to the generator to say, hey, charged, and generator sending back saying, I am. But, you know, obviously the alternator is bad. You know, I'm gonna make that call. There's no question in my mind. We don't have to be concerned with any broken wires to the ECM, simply because we have both our data PIDs, the one the ECM is sending and the one it's receiving, and we can also see the opposite on the generator, the one that's being sent and the one that's being received. So we know it's on, you know, both ends of the spectrum there. ECM has the data and we have the data at the generator. Can't really do a voltage drop on the positive side because there is no current flow. We can do a quick, you know, check on the, you know, generator ground side is with test light, make sure it's good, but, you know, no current flow, no voltage drop, so I'm not super concerned with that. I don't know. I don't have the answer, folks. I'm going to do some research though, but first I'm going to get the okay to throw an alternator on this, get that portion of it taken care of, and we'll grab our data off the new alternator and see, I don't know, see what we see. New and shiny, all installed. One thing before I put this circuits back on, I want to tell you about the Ford smart charging systems. Default, completely removed from the system. So no GenSense, no GenCom, no GenMon, take the ECM right out of the mix. This alternator should charge. What it will do, it's kind of a default strategy. I know a lot of you guys, you know, piss and moan about computers running stuff. I think it's kind of a unique design in the sense that with this unplugged, your alternator should charge. It's going to be at a fixed voltage of 13.7 or 13.8 volts fixed regardless of load. So I suppose quick and dirty. You want to know if your alternator's bad on your Ford? Unplug it. Of course, you still have, you know, connections issues, you know, case ground, battery voltage, and that. But theoretically, if we go start this, it should charge. So we'll hop in here, and we'll see with open circuit if this thing throws a code. No freaking check engine light, and that thing's completely unplugged. We may have to give it a little, toot on the throttle. So right now, battery voltage is 11.5. No fault, of course. So let me just rev it up here, get some RPMs in that alternator. Oh, I hear her singing now. Of course, it's going to idle funny because we've got the air cleaner off it. So what are we at? 13, 13.6, 13.8. So yeah, right around there. That should be regardless of RPM. Gosh, started running kind of crappy there for a minute. Must be whatever his misfire is starting to become evident. But yeah, so we can see alternator completely unplugged, and it works. Awesome. So we made the right call. So everything is hooked back up now. Alternator's plugged in. I'm going to go ahead and start it. I hear the old alternator out there whistling away. We can see the generator command coming up. Then it drops right off. But our battery charging voltage is good. So that's interesting. That's got to be just how it talks. And then I bet if we go look at the scope, we're getting that periodic signal being sent. But we can see the Gen Mon is at 96% still. Of course, we're not meeting our goal voltage because our battery is pretty well spanked. If I rev it up here. So it did dip down there briefly. Of course, I got the mass airflow off it still, so it's not very happy with me. Oh, there it goes. Yeah. Yeah, the car's not very happy with me because the mass airflow's unhooked. Well, I'm gonna take and let the battery charge up a bit. I want to see if this Gen Mon changes or what. We'll go out and look at some data out here. Make sure the wires didn't get chewed up. Oh man. I don't think she's too overly maintained. Look at that air filter. Oh my gosh. Maintenance, people, maintenance. Yep, and there we are. We're getting our 5-second signal again. That's pretty slick, and that's on the Gen Com. So that's from the PCM to the generator. It looks pretty well identical to what we had before. What's interesting though is I haven't moved any of my traces, and I see it's down inside our yellow trace now. But perhaps the yellow trace is at battery voltage. It is. Okay, so our yellow trace is increased, so nothing to be alarmed about there. Our duty cycle on that, 66%. Oops. Of course, that was just on the trace we had, so yeah, it's still running about 98%. Alright. What's our scan data say? Yeah, 96.87. Of course, we've got to wait for this to charge up for a while. So I think we've got some valuable information here. Look what's happening. So our green trace, our Gen Mon, our Gen Com, starting to lose my mind here, folks, is now talking more. All I did is let it sit here and run. And now that the battery's charged, so our charging goal is 13.9, and our actual voltage is a little over 14. So perhaps when it sends those intermittent pulses every 5 seconds, perhaps that's the default strategy to put it into a high charge state. Because now that the battery is, you know, charging up, we can see our command went from 0 back up to about 50%. And our monitor is fluctuating there. So let's see if our real data reflects what we're seeing. We may have just learned something. What's going on here? Whoa, I always go the wrong way. Alright, let me set you guys down. Sure, I set you down and it quits working. But our scan data also reflects that. But what's going on here? So, our desired voltage has gone up. Since our desired voltage has gone up, we're going to go back to that periodic 5-second pulse. Oops, I always go the wrong way. So let's see here. We should get about 1 pulse per division as we're set up here. So we're going to get another one about here. Another one about here. Alright, so that, I think, is safe to assume that that's the strategy when it's in a high charge state. So I'm going to go give it the beans here. We're going to rev it up, get the battery fully charged, and watch what happens. Airflow. Well, there we go. We can see scan data, reflects that. Yep, and there it goes. So it has different charging strategies, and that's all depends. I'm losing it here, folks. And depending on what the strategy is depending on what it sends down the comm wire. So I wouldn't say that we can assume that the periodic signal being sent is an always case. It's going to be dependent on what charging strategy the ECM is telling the generator to output. We're not going to go the wrong way this time, huh? Who's learning their lesson? I'm going to go ahead and rev it up again, get that battery nuked. Look at it on a little bigger time basis here. Do it. Maybe I didn't give her enough rev up. Evidently not. Let me try it again. Well, apparently we're not meeting the right criteria currently. Dang, I was really hoping to catch that again. There she goes. So I just did it briefly there. What it seems to do, I need to save that. It seems to do that after a wide open throttle event. So again, I guess it could be some strategy. Puts them at a fixed 50% duty cycle. Hard to say. Sure is what it seems like. Very interesting. testing. And then when it goes back, now we're running about 53% duty cycle, and all of that agrees with scan data. So I'm going to save that waveform. All right, so before I say the heck with it for the night, I want to get a key-on engine cranking capture from my own library and just kind of see what the strategy is while it cranks and initially starts. Well, there it is. We're back to where we started. That's it, folks. It's 9:30. I'm going home. I am glad that earlier today I ordered an alternator. So I had one on the shelf. So we were able to take care of that quickly. However, I was not just going to bomb a, I don't know, it's like $200 alternator on it on a big fat guess. So even though in this case, you bring it in, it's not charging, what do you need? You need an alternator. You throw it on, you're right. And you'll probably be right 87.6% of the time. It's the other percentage of the time, whatever that is, removed from 100. I should have picked an even number there, huh? The other percentage of the time when you're wrong, it sucks because now you're eating a $200 alternator and scrambling to find the problem. So, with that being said, I hope this video ends up making sense. And some people might think I'm crazy for actually testing an alternator on a no-charge condition. I don't think it's crazy. Of course, I also bill for my time. And I guess it's money well spent because there's no guesswork involved, in my opinion. I would rather pay someone to tell me 100% what the problem is and then, guarantee their work and move on. It just bothers me why that light will not come on, why open-circuited, short-circuited, and short-circuited, to ground and to high voltage on both the COM and the MON wires, plus open circuit on all three wires, it still did not generate a code. And that bothers me, and I'm going to lose sleep over that. And I don't have the answer for it. And I looked for, I did some poking online to see if there was anybody that had any kind of strategy. I looked at code setting criterias. All the code setting criteria, Ford doesn't really have, at least that I found, a good laid out code setting criteria. They have their list of, possible causes in their service manual. So I guess, I don't know, maybe the dealership guy just starts at the top of the list and starts winging parts at it. I don't know. I don't know why they list the possible causes. But in that list was, short to ground, short to voltage, open circuit, it gave the whole list of everything, every scenario that I tried to recreate, yet failed to generate a code. So there's either more to the code setting criteria, perhaps, engine RPM for, sustained time, or vehicle speed, or, some other input, maybe, Prindle input. I don't know. All I know is that this alternator was junk, and it was not turning on the light, nor was it setting a code. But the ECM, we know, is in charge of both of those. I'm tired, man. I'm ready to go home. So, Google+, Facebook, check us out there. And also to subscribe to our channel if you haven't. If you enjoy these videos, especially the ones that I don't initially intend to shoot, but end up doing it anyways, even though it takes time. And if you appreciate that, consider checking us out on Patreon now. Links in the description below, links up here on the screen. And you can help support the SMA to help keep it a free YouTube channel and kind of keep us going, keep us motivated. So, all right, guys. If I can do it, you can do it. Thanks for watching.